Neutrons add to an atom's mass because they have mass, but do not change the atom's electric charge because they carry no electric charge. Think of an atom like a tiny solar system with a central nucleus made of protons and neutrons and electrons orbiting around it. Protons are positively charged, electrons are negatively charged, and neutrons are neutral with no charge. Since neutrons have mass similar to protons, adding neutrons makes the nucleus heavier and increases the atomic mass, which is the total mass of protons plus neutrons. Because neutrons are electrically neutral, they do not add or remove positive or negative charge, so the overall charge of the atom depends only on the difference between protons and electrons. When the number of electrons equals the number of protons, the atom is electrically neutral regardless of how many neutrons it has, but the extra neutrons still make the atom heavier and can affect how stable the nucleus is. A common mistake is thinking that neutrons somehow cancel proton charge simply by being present, which is not true because only charged particles affect electric charge. The simple fix is to remember charge comes from protons and electrons only. Another misconception is assuming atomic mass equals the number of protons alone. The clear correction is to count both protons and neutrons to get mass, while charge comes from protons minus electrons. Students sometimes think adding neutrons cannot change chemical behavior at all, but it can change nuclear stability and sometimes physical properties like density. So remember, neutrons influence mass and stability even if they do not change electric charge. For more videos and resources on how subatomic particles affect atoms, check out www.gumballdegree.com.